You're okay. Okay. So here's how this is going to roll. You need your sum and difference formulas. You need them out. You need them ready to rock and roll. What you're doing is you're trying to find the exact value of these functions. But if I ask you for the sine of 105 degrees, do you know what 105 is? So if you do 105 divided by 180, it's not going to be an angle that you know. An angle that you know being one of these. Okay? So what you need to do is you need to break down by either adding or subtracting. Now, most of you are going to find adding is going to be easier because it's just an easier operation. You're going to want to break down the angle that you're given into two angles that you know. So the angles that you know are, you're never going to use 0 and you're hardly ever going to use 90. So the angles that you know are pi over 6, right? You know pi over 4 and you know pi over 3. And then you know the different values based on the quadrants, right? Pi over 6 is 30 degrees. Pi over 4 is 45 degrees. And pi over 3 is 60 degrees. Okay, you know those. That might be on the top of this page. These, you might want to write those down. Okay, you might want to write those down because those are the angles you're going to use. Pi over 6 goes to 30. Pi over 4 goes to 45. And pi over 3 goes to 60 degrees. And you're not going to use 0 and you're not going to use 90. You're not going to use 0 and pi over 2. Let me put these up. Okay. All right, cool with me there? Yeah? So now, example 1. Is it in radians or is it in degrees? Degrees. Degrees are going to be a lot easier. A lot easier because radians always have fractions. And you guys, as much as I love you, fractions are not your strong suit right now. So, using the angles that you know right here, using these, can I use these in any way to get 105 degrees? Yes, no, maybe. The answer is yes, right? Which two, it's always going to be 2, which 2 of these angles over here am I going to use to get to 105 degrees? Since it's in degrees, let's use degrees. 60 and 45. Does it matter which way you add them? Absolutely not. So I'm going to write this as the sine of 60 degrees plus 45 degrees because that's exactly the same. Agree? Yes, no, maybe. Okay? Now, what you're going to do is this is a sum formula. So if you go to your booklet, it's going to say the sum, it's going to say the sine of alpha plus beta equals, and it's going to have some big formula, right? And that formula says sine of alpha, cosine of beta, plus cosine of alpha, sine of beta. It's what it says on your paper, right? It's what it should say. Alpha and beta are your two angles here. That's all I did. Does everybody see it? This is from your booklet, okay? The difference here is I have an angle plus an angle. Yeah? Here, I have an angle plus an angle as well. Agree? Yes? So now I'm going to use what that equals. In this case, alpha is 60 degrees and beta is 45 degrees. Does that make sense? First angle is alpha, second angle is beta. Come on. Yeah? Yeah. Okay. So now I'm going to use my formula. That says this is the same as the sine of alpha. What is alpha in this case? 60 times the cosine of beta. Beta is 45. Plus the cosine of alpha. So I'm going to write the cosine of 60 times the sine of beta, which is 45. Is everybody okay with me there? Now from here, you have to use your unit circle. You have to use your exact values. This is key. I want an exact value. So you go, if you don't have it memorized, take a little bit of time and write your chart out really quickly. Here, write your chart out. Do you guys want pieces of paper to write your chart out? Write your chart out really quickly. Here. Here. And maybe keep it for a while so you remember where it is. Let me cut these in half. Because you got it. The thing is you got to know the chart pretty much right away. I'm going to cut them in half. Hold on. You got to know the chart pretty much right away to solve these. If you don't know the chart right away, then it's not going to do you any good. If you want a piece of yellow paper to write on your chart, go get it really quickly and write them within 30 seconds, please. Write it really quickly. Your goal is to have it 100% memorized. Courtney's probably got a number. I'm pretty sure I have to do it. You probably do. I will say probably by the end of the week, you're going to have it memorized. You don't have to write it down anymore. Okay, I'm giving you like 10 more seconds to write it down. Okay? Now, from here, you use your chart and find it. What is the sine of 60 degrees? 60 degrees is pi over 3, yes? What is the sine of pi over 3? That's what? It's radical 3 over 2. If you don't have the right values, your whole thing's wrong as well. Okay? Just heads up. Cosine of 45 degrees. 45 is pi over 4. The cosine of pi over 4 is? It's radical 2 over 2. Plus the cosine of 60 degrees. Come on, guys. What is it? That's 1/2. Times the sine of 45. Radical 2 over 2. We got to have it that quick. Because if you notice here on 5 and 6, what am I introducing? Tangents. Tangents are not as easy for you guys. Sines and cosines should be fairly easy. Now from here, I have a fraction, yes. Fraction times a fraction, yes. Fraction times a fraction, yes. How do you multiply fractions? Straight across. What's radical 3 times radical 2? That's a square root of 6. 2 times 2, 4. Plus, multiply your other two fractions. 1 times radical 2, radical 2, 4 times, or 2 times 2, 4. Am I adding fractions here? How do you add fractions? Do you already have a common denominator? Do you have any like terms? Are radical 6 and radical 2 like terms? No. Because, yes, they're both a radical, right? But they're not. They have to be like terms. Underneath a radical, they have to have the same radicand. So same whatever's underneath. And the same root. They have the same root, but they don't have the same radicand. So you will simplify this so it will look like this. Radical 6 plus radical 2 over 4. That's your final answer. Yeah? Okay. Number 2. We need to find two angles that we know that add to get to 165 degrees. I'm going to tell you, if you ever see a 5 in it, what's one of the angles you have to use? 45, right? Okay.
You can only use
2.
like you can use 2 2s and 1.
Nope. Because look, I only have 2 angles in my sum formula. And the same with the cosine. I guess I should have written that down. Cosine alpha plus beta equals cosine alpha, cosine beta, minus sine alpha, sine beta. 2 angles. What's one of them? 45. So how do you find the other one if one is 45? Subtract, right? What's 165 minus 45? 120. Is that allowed? Do I only know 30, 45, and 60? No. Do you know what 2 pi over 3 is? 2 pi over 3 something that I could ask you on a speed quiz? Yeah? Second quadrant. 2 pi over 3 is 120 degrees. Guys, how would I, so here's how you can figure this out. Look and listen. How do I go from 60 to 120? You multiply by what? 2. So what I'd have to do over here as well, multiply by 2. Well, the 2 would go in the numerator. 2 pi over 3 is the same as 120 degrees. We have to be able to, like, maneuver. Okay? Yes? So this is the same as the cosine of what plus what? Just give me the 2 angles we just talked about. 45 plus 120. Always has to be 2 angles. What's alpha? 45, yes. What's beta? 120. Does everybody understand that? So now you plug it in. Now you're going to use right here. So this is the same as the cosine of alpha. What's alpha? It doesn't matter. Sorry, what's alpha? In our case, 45 times the cosine of beta, which is 120, minus. I will now put this in parentheses. Why am I going to put in parentheses? So you don't forget to distribute. Sine of alpha, so that's a sine of 45, times the sine of beta, which is the sine of 120. Everybody okay with me there plugging it into my formula? Yes? Now we have to get the exact value. So now we're on this step right here. What is the cosine of 45 degrees? Radical 2 over 2. Cosine of 120. So we just said 120 is 2 pi over 3, right? Cosine of 2 pi over 3. This is speed quiz just like we would do it, right? Because I believe I have cosine of 2 pi over 3 on that thing. So cosine of 2 pi over 3, what's my reference angle? Pi over 3. What's the cosine of pi over 3? You have it written on your sheet of paper. Cosine of pi over 3 is 1/2. 2 pi over 3 is in what quadrant? Second. Cosine is negative. So this is negative 1/2. Minus, what is the sine of 45 degrees? Radical 2 over 2. It's the same as cosine. Times the sine of 120 degrees. Okay, 120 degrees is 2 pi over 3, right? Reference angle still? Reference angle is pi over 3, right? Sine of pi over 3, radical 3 over 2. It's in the second quadrant. Radical 3 over 2 is positive. Okay, what do I do from here? Multiply. So radical 2 times negative 1 It's negative radical 2 over 4 minus what? So what do I do with radical 2 and radical 3? Multiply, so minus radical 6 over 4. Do you already have a common denominator? Yep. So this can simplify to negative radical 2 minus radical 6 over 4. Yes, no, maybe. Okay. No lie, I believe that degrees are 1,000 times easier. They are. They just are. All right. So number 3 is in radians. Now, what is my denominator? Those are easy. What's my denominator number 3? 12. Okay, now here's what you need to do. Can I use these two denominators and get to 12? You could, because it would get you 24, but you could possibly simplify to get to 12. Agreed? Can I use these two to get to 12? Can I use these two to get to 12? No, that's 18, probably not. Do you see what I mean by that? Do you see what I mean by that? So, when you have radians, start with the one that screams you're going to get 12 in the denominator. Which one screams I'm going to get 12 in the denominator? 3 and 4, right? 3 and 4. With this is a very much play until you get it correct. Now, if I have a piece of scrap paper here. Why do you think I'm a piece of scrap paper? Because I'm going to have to play around a lot. So if I have 19 pi over 12, I need to get that, and I would always suggest you add as much as you can. I need to get that using something over 4 and something over 3. Agree or disagree? Yeah? So something over pi over 4 and something pi over 3. Okay, now, if I take these two and I get my denominator to 12, which is what I want, yeah? What did you have to do to the 4? Multiply by 3, so this becomes 3 pi, yes? Yeah? Plus, what did you have to do here? So this becomes 4 pi. So it's technically 7 pi over 12. Yes? Now you have to play. We need to get 19 pi over 12. You play with these numbers. Now, here's where the more you have that number sense, easier it's going to be. I immediately see, now this is me, I immediately see if I take 19 and subtract 4, that's 15, yes? How do I get 15 with 3? You can multiply by 5. Did everybody see what I did? Or I say, if I do 19 minus 3, what is that? What would I have to multiply this by? 4. Do you see how there's going to be different ways of doing it? I don't care how you see it. I just want you to see it. And you're going to get the same answer no matter what. Okay? You have to play around a little bit. I would suggest when you're doing this for your homework is you are really having an extra piece of paper to play around with it because you're going to have to do them tonight. Just no ifs, ands, or buts about it. So, and I promise you, if you come in tomorrow and say, I didn't know how to do anything, I'm going to speed up my teaching to like 5 times as fast as I'm going today. If you tell me in tomorrow and say, I didn't know how to do anything without letting me know prior, and that doesn't mean stopping by my room, if you don't let me know where you got stuck, it's pushing a button you don't want to push right now. Okay? So, would you guys like me to use the 3 pi or would you like me to use the 4 pi? It doesn't matter. Let's use the 4 pi. So if we keep the 4 pi here, this pi over 3 is going to stay the same. Yes? But what do I have to do to this 3 pi? You'd have to multiply it by 5. So this actually becomes 5 pi over 4. Because I needed to get to 19. Yes? I did 19 minus 4, which is 15, right? And how do I get 15 using 3s? I have to multiply by 5. Okay? So now if you do it, if you would multiply this by 3, you would get 12. Multiply this by 3, you would get 15. So I'm going to now separate this. So this is now going to say the cosine of 5 pi over 4 plus pi over 3. Once you get here, the rest of it should be a cakewalk. Because all you're doing is you're using a formula. All you're doing is using a formula. So this is the same as the cosine of alpha. What is alpha in this case? 5 pi over 4 times the cosine of beta, which is pi over 3, minus the sine of alpha times the sine of beta. Finish this problem. Yes, ma'am. Finish this problem, please. How did I get what, sweetheart? Yeah, so I said, so this simplified. That is that simplified. I knew I didn't multiply this one by 5. That's why the 5 went up there. Is that what you were asking me? So if you did 4 divided by 12, you get pi over 3. And if you did 3 over 12, you get pi over 4. But I know I need 5 of these, which is why the 5 went there. This is if I get a common denominator of 12, it gets me right back up to 19 pi over 12. Because if I multiplied this across, it would be 15 pi plus 4 pi over 12. You guys should be finding an exact value right now. And 15 plus 4 pi, 19 pi. Oops. That's what you should get. We're going to do one more together. I'd really like to get to tangent, Miss Bonnet comment. Yes, ma'am. 1/2 right here. 1/2. I just had a brain fart and I was about ready to write radical 3 over 2. And I didn't erase it. Okay. 4. Okay. 4. What you think? Where are we going to start? We need negative 5 pi over 12, right? So I'm probably going to use what and what? Pi over 4 and pi over 3. But am I going to be able to add these two? I mean, you can, but you're going to be adding a negative, which is the same as subtracting. So if I subtract, I need a negative, so my bigger number should go on the right, correct? Small minus big. So which fraction is bigger, pi over 4 or pi over 3? Pi over 3. So this is going to be pi over 4 minus pi over 3. We're starting the same way we did last time, right? So I'm going to do 12. So this is going to be 3 pi minus 4 pi. I want you to sit and think and see if you can figure it out.
We're trying to get -5.
Yep, -5.
4 times 2 minus 3.
Yeah, because if you did 3 minus 8, that's -5, right? So this become, what do I have to multiply this by? 2. So this becomes a what up here? 2, right? Does everybody follow me there? So then I'm going to write this as the sine of pi over 4 minus 2 pi over 3. And I believe you have the difference formulas on there too, don't you? Doesn't it say sine plus or minus? I don't remember. Doesn't it say sine plus or minus on your paper? Oh no, they're all separated. Man, that is cakewalk. They're all separated. So now you're going to come over here. So you're going to have the sine of alpha with the sine of alpha. So it's the sine of pi over 4 times the cosine of beta. So 2 pi over 3. Yeah? Does everybody follow where I'm getting this?
Is it negative?
Nope. Nope. You're taking care of the negative right here, Tyler. Keep all your angles positive. Minus the cosine of alpha, so pi over 4, times the sine of beta, 2 pi over 3. Does that make sense, kiddos? Yeah? Plug it in. Okay. What is the sine of pi over 4? What? Yep. And what's the cosine of 2 pi over 3? -1/2. Do you see how those positive and negatives will kill you? Here, you got to be careful.
I didn't think you were asking for like the whole thing entirely. I thought you were just asking what it was.
Oh, I see what you mean. Yeah. Cosine of pi over 4. Radical 2 over 2. Sine of 2 pi over 3.
Wait, why is the 1/2 negative?
Because this is in the second quadrant and cosine's negative in the second quadrant. This is radical 3 over 2. Yeah? So I get negative radical 2 over 4 minus radical 6 over 4. So negative radical 2 minus radical 6 over 4. Are you guys noticing something? It's always going to be over 4 for the most part. They're almost all the same answers, but they're in different orders, right? So